Okay, want to do a couple of Algebra 2 questions because I'm tutoring a couple of students who have a test over rational functions coming up. These are two pretty straightforward questions, definitely ones that you would see on an ACT test. Find any points of discontinuity for the rational function. So as a reminder, the rational function is also called the reciprocal function. 1 over x is the parent function. And one of the important behaviors is that it has discontinuity whenever the denominator is equal to 0. And that is called a vertical asymptote. So here in this image here, we see that this graph has a vertical asymptote at x is equal to 3. So it's an imaginary line that the graph will not cross. So a discontinuity means the graph breaks. So when they ask these questions, they're testing that you understand that the graph is discontinuous when the denominator is equal to 0. So that's one location for discontinuity. The second place for discontinuity is called a hole. And a hole is, again, because you get an expression in the denominator that's equal to 0 that cannot exist because it's undefined at 0. And so we call that a hole. And it'll just be it'll be a point where at that particular point, the graph just cuts off and it skips that point and then it continues on. So these are the two types of discontinuities we will be looking for in these two problems. Number one, find any points of discontinuity for the rational function. In this function, you can see that the denominator is expanded, so we need to factor it first in order to find out where the graph will be discontinuous. So x squared minus 2x minus 8. What two numbers multiply to negative 8 but add up to negative 2? Well, to get negative 8 is negative 4 and positive 2. And since the b is negative, these are the correct factors, x minus 4 and x plus 2. Okay, secondly, you need to check to make sure that there's nothing that can cancel out. So we look at the numerator and the denominator and we see there is nothing that is the same, so nothing will cancel out. So we will only be looking for a vertical asymptote. So the vertical asymptote, there will be 2. So we take x minus 4 and make it equal to 0. Therefore, x is equal to 4. So when x is equal to 4, the denominator will be 0, undefined. We cannot divide by 0. So that's one location. And we take x plus 2 is equal to 0. So when x is equal to negative 2, again, if you plug that in, your denominator will be 0, another location. So this has 2 VAs, and the answer is B. Positive 4 and negative 2. Do not fall for A. That's called a distractor. A lot of students will think that the factors are what you're looking for, but no, you have to make it equal to 0 and get the actual solution or the actual values where the graph has a vertical asymptote. So that's the first question. Let's look at the second question. Same thing. This one's a little bit easier because it's already factored. So once it's factored, the second thing we do is we check to see, is there anything that's the same at the top and the bottom, in the numerator and the denominator? And here we see that x plus 5 is in the numerator and the denominator. So that means we have a hole at x plus 5. So we take x plus 5, make it equal to 0. So x is equal to negative 5. So when x is equal to negative 5, there will be a hole, there will be a removable discontinuity, in the graph. So that's 1. Let's see what's left. We have x minus 2 over x plus 3. Okay, now we still have the denominator. We will have a vertical asymptote at x plus 3. So we take x plus 3 and make it equal to 0. So x is equal to -3. So we are looking for an asymptote at -3 and a hole at -5. -3, -5. So and again, another distractor answer. They have asymptotes -3 and -5. If you chose that, that would be the wrong answer because these are not. Only one of them is an asymptote, the other one is a hole. So A is the correct answer.